In this video, we will cover the private VLANs. A private VLAN is a feature used in network design to enhance security and segmentation within a single VLAN. So it allows more granular control of traffic and isolation between devices within the same VLAN. So devices within the same private VLAN can be isolated from each other, preventing direct communication between them while still allowing them to communicate with a designated common gateway or server. So private VLAN provides additional security by restricting how devices within a VLAN interact with each other, guys. So there are some components that we need to know about private VLAN. So first of all, the primary VLAN. Primary VLAN is the main VLAN that encompasses all the secondary VLANs, okay? And then we have the secondary VLANs. Our secondary VLANs may be isolated or the community VLANs. So devices in an isolated VLAN cannot communicate with each other, but can communicate with devices in the primary VLAN or a designated promiscuous port, as you can see on the left side of the screen. On the other hand, devices in a community VLAN can communicate with each other as well as with the promiscuous port, but not with devices in isolated VLANs. So you are seeing the community VLAN example on the right side of the screen. Okay, so guys, private VLAN port types determine how devices connected to a switch port interact within a private VLAN setup. So we have some primary port types, and they are promiscuous port, isolated port, and the community port. The promiscuous port can communicate with all other ports within the private VLAN, including the isolated and community ports, and this is typically used for gateways that need to interact with all devices in the private VLAN. So as you are seeing in here, the port going to the router is defined as a promiscuous port in both scenarios. And we have the isolated port. So these ports can only communicate with promiscuous port and cannot communicate with the other isolated or community ports within the same private VLAN. So it is used for devices that require isolation from other devices in the same VLAN, such as individual client machines. And we have the community ports, which can communicate with other ports in the same community VLAN and with the promiscuous port, but not with isolated ports or devices in other community VLANs. So this is very much suitable for groups of devices that need to interact with each other but remain isolated from other groups or isolated ports. So in summary, guys, private VLAN ports are categorized as promiscuous, which communicates with all ports, isolated, which communicates only with the promiscuous port, and the community, which communicates with other community ports and the promiscuous port. So these types enable flexible traffic control and security within a single VLAN. Now let's see how I can do the private VLAN configuration. Let's have a look at our topology first. In our topology we have two different servers, server 1 and server 2. But please pay attention that they are in the same subnet. I mean, like, they have the same network ID, which is 192.168.0.0. And server 1 is connected to Fast Ethernet 03. And server 2, it is connected to Fast Ethernet 05. And I have my Fast Ethernet 01 port, which is connected to my router. So the goal in here is restricting the traffic within the same VLAN. So I don't want server 1 to communicate with server 2 and vice versa. So how we can achieve it? Let's see the configuration. First of all, I need to set device to VTP transparent mode. Okay, if you just want to configure the private VLAN, you need to set the VTP mode to transparent VLAN. The second thing, I need to define my secondary VLANs that will be used within the primary VLAN. So you need to configure isolated VLANs for complete isolation or community VLANs if you need. So what I'm doing, I'm going ahead and I am defining my isolated VLAN. So VLAN 101, the command is private VLAN isolated. Then I'm going ahead and defining my primary VLAN. So this is the main VLAN that contains the secondary VLANs. Okay, it serves as a container for the secondary VLANs. How I am mapping the secondary VLAN to primary VLAN is by using private VLAN association 101, which is my isolated VLAN. Then in the third step, I'm going ahead and defining my port types like promiscuous or host. Okay, for example, Fast Ethernet 01 will be the promiscuous port, and then I am assigning switch ports to the private VLAN. So ports can be assigned to primary VLANs with specific types of secondary VLANs. So the command is switch port private VLAN mapping 100 and 101. Okay, this is the configuration for Fast Ethernet 01. And then I'm going into the Fast Ethernet 03, and this time I'm typing switch port mode private VLAN with the port type host, and then I am doing the same host association with 100 and 101. And lastly, I'm going into my Fast Ethernet 05, typing the switch port mode private VLAN, which is type host, since there are hosts connected to it, both will be host. And then I'm typing switch port private VLAN host association and my primary VLAN and the secondary VLANs. So the only difference when you're defining a promiscuous port and the host port is just you type private VLAN mapping for promiscuous. On the other hand, you type private VLAN host association for host ports. So after this configuration, even these guys are in the same VLAN, you will be able to see server 1 will not be able to communicate with server 2 and vice versa. Okay guys, we are coming to end of this section as well, and thank you so much for listening to me.